Hierarchical cluster analysis with Navure. Hierarchical cluster analysis encompasses a set of unsupervised methods designed to categorize instances based on their similarities. This categorization results in the formation of a hierarchy, allowing for the exploration of interrelationships among instances. The hierarchical structure reveals the inherent partnerships or associations existing within the dataset, offering insights into the natural groupings and affinities among the analyzed elements. We will illustrate this application using the Prosopis origin dataset found in the test data repository. This dataset consists of 138 trees belonging to 23 origins, where each origin is represented by 6 trees for which heights were collected at 30, 60, and so on up to 505 days after transplanting in the field. The purpose of the clustering analysis is to group the origins according to their heights over the study period. Once the file is open, click the Multivariate tab and click the H-Clustering button. In the dialog box, select the heights and drag them to the Traits panel. Since we want to group origins, we drag Origin to the Grouping Factors panel. If we skip this step, we will be grouping individual trees, which is not our goal in this case. Let us explore options. Click the blue play arrow. In the emerging dialog box, you will find several options. At left, a set of panels that offer several ways to measure dissimilarity between the instance to group. The measurements are grouped according to the nature of the traits used. If the traits, like in this case, are metric, the default Euclidean distance is usually okay. There are several options to choose from. If you are curious about the measurements calculation, the hint in the info button at the right corner of each panel will give a hint. Note, the clustering algorithm always uses a dissimilarity measure between instances. However, you will see several similarity indices listed, but they are transformed into a dissimilarity for the purpose of clustering. For a complete reference, see the documentation of the R language proxy package. On the right side of the dialog box, there are 3 panels. The first, Clustering Algorithm, allows you to choose according to your preference. Ward.D is the default. Each algorithm has its pros and cons. Consult a textbook on multivariate analysis if you need help on this topic. The panel summarization allows you to decide how to collapse into one profile the replicates found in the data set for each class of the grouping factors. By default, it is set to the mean. This implies that the 6 trees, belonging to each origin, will be averaged before entering the analysis. The Options panel contains several alternatives regarding processing and output. By default, they are all checked. When the number of instances that you want to group is large, you may not want to generate a dendrogram, the typical graphical representation of a hierarchical cluster result. This is because you will not show the details that make the dendrogram useful for interpretation purposes. In this case, uncheck the Show Dendrogram option. Standardize option is almost a must, and you shouldn't uncheck it unless you have reasons to use the original scale of the variables as their weights during classification. Save classification is probably the most important output you are looking for. When this option is checked, a new column appears in your data set with the cluster number assigned to each case. Since you are grouping origins, all trees within an origin will have the same cluster number. Generate sequence is an option that works in conjunction with the number of clusters TO generate. If it is set to 2, it has no effect, but if it is set to 3 or more and generate sequence is checked, the algorithm is applied sequentially to generate 2, 3, and so on clusters until the specified number of clusters TO generate is reached. For each number of clusters, a new column is added to the data set. They are named K2, K3, and so on. Dendrogram is only generated for the highest number of clusters. When you click the OK button, the most relevant outputs are the dendrogram showing the way the groups are created and the columns with the resulting classification of the cases in the dataset.